We'll proceed in parameterization of surface, parameterization of volume, Jacobian 2D, 3D in calculus. So we are in a phase, to prove the 2D Jacobian, 3D Jacobian. So that is the idea. 2D, 2D, 2D Jacobian, 3D Jacobian. What is two-dimensional parameterization, three-dimensional parameterization? Parameterization of a surface and parameterization of a volume. So, if I convert dxy plane into duv plane, then it is parameterization of a surface. If I convert dxyz plane into duvw plane, then it is parameterization of volume. 3D Jacobian comes into the picture. So we were in a run to prove the 2D Jacobian, where 2D Jacobian is used. Typically, a single example, the same example, would talk about a 2D Jacobian and 3D Jacobian. Same example. Like I'm trying to calculate volume of a sphere. I'm trying to calculate volume of a sphere. Okay, so I had a sphere here only. So this is the sphere and this is xy plane. This is origin, blue color, and this sphere is centered. I pierce it and it will go and stick here. This sphere is centered at the origin. What is the volume of the sphere? If I have a surface on top of xy plane, if I calculate this integration of this surface along xy plane, then it will talk about volume of the surface underneath it. Like I have always given example, if there is x-axis, this is x-axis and this is the curve. If I integrate this curve along x-axis, whatever you see, this area that is will get calculated after the integration. If I have a surface, now the surface would map some region in xy plane. So this surface, if I come down, whatever volume it is covering, that volume will get calculated after integrating the surface along xy plane. Okay, so that is the scenario. So I can calculate the volume of this sphere with xy plane. So it is now the integration over the region. What is the region? If this is the surface and this surface maps into one certain region in xy plane, that is a circle, then integration over this circular region and then fxy dxy plane dx dy. What is other way calculating the volume? We can go for triple integration. Triple integration. Triple integration in the sense that xyz volume. Right now we have xy plane region in double integration or integration over xy plane region on which the surface maps. Okay, now there will be a triple integration or integration for the full volume of the surface, full volume of this material. So x, if it is a sphere, then x would expand minus a to a. A is the radius of a sphere, minus a to a, y minus a to a, and z. Z. Now someone will say minus a to a, or if I'm talking about top hemisphere of the this sphere, this sphere is centered at the origin. This sphere is centered at the origin. Then upper hemisphere of the sphere is above the xy plane. So z equal to 0 to a, x equal to minus a to a, y equal to minus a to a. Okay, this is x axis, this is y axis. If this is centered at the origin, then x is minus a to a, y minus a to a if it is a sphere. Z equal to 0 to a, it is hemisphere, not true. Z is not independent component. Z is dependent upon x and y, fxy. So z will be 0 to a square root of a square minus x square minus y square. If you are working in calculus, then this is modified algebra or algebra that is being talked in different terminology, that is called dependent and independent. Calculus works in dependent and independent. Function over x means y equal to function over x means y is dependent upon x. Z equal to function over x and y means z is dependent upon x and y. Both x and y are independent. This is how machine learning and artificial intelligence also comes into the picture. What is dependent? What is independent? Like features. Again, each observation in machine learning, there are features. Feature must be independent to each other. Otherwise, it will produce collinearity. And if it produces collinearity, then there is a problem. Then you go for dimension reduction ability and come with the orthogonal features. Feature must not be dependent upon each other. Changing one value should not change other value. If I change x, then y would remain there only. But if I change x, z would change. If I change y, z would change. Z is dependent upon x and y. So if I take triple integration, then x is minus a to a, y is minus a to a, z is 0 to a square root of a square minus x square minus y square, because in a sphere x square plus y square plus z square equal to 1, equal to a square, a being radius. So mind it, what is dependent and what is independent. Now the d volume, d volume, if I take, that is dx, dy, dz in Cartesian coordinate system. Now dx, dy, dz. Okay. Now finally, if you see this, then if I try with z first, because z is dependent upon x and y, then it will come as z as integration and 0 to square root of a square minus x square minus y square. At the end, it will come as square root of a square minus x square minus y square dx dy only. Or so, or that in 2D, when I talked about 2D, this is 3D way of calculation. 2D way of calculation is integration over region on xy plane fxy dxy. So anyway, there are two things. One is fxy dxy plane, and one is 1 or what, nothing, and dv. dv is dx dy dz, where x is minus a to a, y2 is minus a to a, that is the region on xy plane, and z is the dependency for upper hemisphere 0 to a square root of a square minus x square minus y square. Okay, so this is the scenario for 2D. For 2D case, now when I know that I am not going to calculate it in Cartesian coordinate, it is very difficult. So we will take help of another coordinate system UV, where x equal to v cos u, y equal to v sin u, uv plane, or instead I can say it is uv plane, or instead I can say r theta plane, theta r plane. Then x equal to r cos theta, y equal to r sin theta. If this is x plane, then there is another plane that is coming into the picture, that is uv plane. Or if this is xy plane, then this is uv plane or theta r plane. Both are Cartesian. So theta axis R axis, or U axis, V axis, and then X axis, Y axis. If this is XY plane, then this is Z, that is function over X and Y. If this is XY plane, then XY itself is function over U and V. So Z is function over X and Y. It considers X and Y are independent, where X and Y now it is dependent upon U and V, or theta and R. So this is called delegation in designing term. Z thinks that X and Y would do the work. X and Y is delegating the work to UV plane or theta R plane because it is difficult. So whatever computation for integration purpose, if once integration is done, then it can take back the things in XY plane. So we have talked in detail. Please watch previous video. Or if integration is done, the limit is still in XY plane. That need to be converted to theta R plane. Then scenario is done. So if I take theta R plane, x equal to R cos theta, y equal to R sin theta, then this region, xy plane region, which is circular in nature, that theta will go 0 to 2 pi and R would go 0 to a, and then fxy, square root of a square minus x square minus y square, would become a square root of a square minus r square. Dx dy, dxy plane cannot be converted directly to d theta r plane, not possible. X equal to r cos theta, y equal to r sin theta. Dx in terms of theta I can calculate, but r I cannot take constant because r is also variable. R is variable, theta is variable. So dx by d theta, dx by dr means it is kind of convoluted, not possible. If there was one independent component on which x was dependent, then dx by d theta I would have calculated. But r and theta both are independent. In that case, dxy plane, there are three proofs that how I can convert dxy plane to duv plane. Dx dy will get converted to d theta dr with some prize money before that. That's how dx dy will get converted into d theta dr. This is then now if there are three ways I can convert it. The first way is our way. Dxy plane is nothing but dxy plane by duv plane or d theta r plane into dr theta plane, d theta r plane as per multiplication. So d theta r plane is nothing but d theta dr. Whatever came extra is dxy plane by d theta r plane. Okay. Through first, please watch exactly previous video. So this method, the dxy plane by d theta r plane, is called Jacobian. Extra thing, dx dy to d theta dr. If I want to convert dx dy to d theta dr, I have to add some more thing in between, in front of d theta dr. That is Jacobian. So dxy plane by d theta r plane is a Jacobian into d theta dr. So dx dy cannot be converted directly to d theta dr. Something else will come along with the prize money, extra thing. So that is called Jacobian. So Jacobian, what is dxy by d theta r? That we have seen. It is nothing but cross product of dx by du I plus dy by duj, one vector, cross product with dx by dv I plus dy by dv j. Whatever comes, that is the Jacobian. Or in theta, dx by d theta into dy by dr minus dx by dr into dy by d theta. Or dx by d theta I plus dy by d theta j, one vector, cross product with dx by dri plus dy by dy by drj. Calculate the cross product, you get the Jacobian. What is the other proof that is available in the now? two proofs that are available in the book, internet, wherever. So that proof is converting dxy plane or dx dy into d theta dr. Now consider I have r theta r plane, and I have xy plane. In theta r plane there is a rectangle. In theta r plane there is a rectangle. This rectangle is mapped to some area region in xy plane. May not be rectangle. Now this rectangle is divided into n along x-axis, n along y-axis, n subsection. So there is n into n square subsection in xy plane. The rectangle, sorry, in UV plane. The rectangle in the UV plane is divided into n subrectangles, where each rectangle can be denoted as I comma j. So rectangle 0 comma 0, rectangle 0 comma 1, rectangle 0 comma 2, rectangle 5 comma 5, rectangle 5 comma 6, rectangle n minus 1 comma n minus 1. So now I take any ijth rectangle, subrectangle. Now if I take a subrectangle, the bottom and left corner, consider it is u comma v. If it is u comma v, the subrectangle width is delta u and height is delta v. Delta u, delta v. Bottom left corner is u comma v. So bottom right corner is u plus delta u. Bottom and top left corner is u comma v plus delta v. Now this subrectangle is mapped into the xy plane as a parallelogram as per the book. This is what we don't like. Mathematics is not approximation. Never. Mathematics is the most solid thing in the world. On top of mathematics, physics, chemistry, biology, or whatever, everything sits on top of mathematics. Mathematics, you may not discuss about physics. Mathematics, you may not discuss about chemistry. Mathematics, you may not discuss about any social science. Mathematics, you may not discuss about any biology, not required. But in all the science, mathematics is required. So mathematics is the most happening thing, the most prominent thing, most fixed thing. Nowhere approximation is required. If mathematics sits on top of approximation, what will happen to the layers? They sit upon mathematics. So if I have a rectangle, a subrectangle, and it is mapped to some region, and imagine it is a parallelogram. It is so infinitesimally small, delta u, delta v, that it mapped into delta x, delta y, and that is a parallelogram as per the book. Now, if I have a parallelogram and one side is a vector, another side is b vector, then cross product of a vector and b vector gives the area of the parallelogram. So whatever the area, whatever the subrectangle I am talking about, that is width is delta u and height is delta v, and bottom left corner is u comma v. Now x is function over uv, x equal to g in braces u comma v, y equal to h u comma v. If that is the case, then the parallelogram I am talking, the bottom left of the parallelogram is x comma y, that is g u comma v comma h u comma v. And then the a vector I am talking is the bottom right portion, that is x plus delta x comma y, that is g u plus delta u, gu plus delta u comma v, and h u plus delta u comma v. That is the a vector's 2 points. B vector, the top point, is now that is x, that is x comma y plus delta y. If that is the case, then g u comma v plus delta v, h u comma v plus delta v. So a vector is nothing but difference of these 2 points of the parallelogram, that is a vector. So A vector is G u plus delta u comma V minus G u comma V. Other is H u plus delta u comma V minus H u comma V. This is A vector. B vector is G u comma V plus delta V minus G u V. H u V plus delta V minus H u V. This is A vector and this is B vector. Okay. So the A vector A cross B, the A vector can be represented as A vector can be represented as G u plus delta u comma V minus G u V divided by delta u multiplied by delta u. Okay. Similarly, H u plus delta u comma V minus H u comma V divided by delta u into delta u. So delta u I can keep outside and this term will become dg by du comma dg by dv. One is I, one is j. dg by dui plus dg dh by duj and then multiplied by delta u. Similarly, B vector becomes dg by dv I plus dh by dv j multiplied by delta v. If I take cross product, then it becomes dg means dx by du I plus dx by dx by dui plus dy by duj delta u cross dg by dv I plus dg dh by dv j and then delta v. All along it becomes dx by du into dy by dv minus dx by dv into dy by du. Braces close, delta u delta v. Mind it, this belongs to the ij subrectangle, this one. If I add for full rectangle in uv plane, all the rectangles, this is for I comma jth subrectangle, we have computed the kind of A cross B vector. Okay, if I add for all, then I have to add for all. Riemann approximation it is called. Then net it will become dx by du I plus dy by duj cross product with dx by dv I plus dy by dv and then du dv. That is A cross B. So A cross B, what is A cross B? Every time I'm saying A cross B, A cross B, A cross B. If A cross B, this is A vector and this is B vector in xy plane. A cross B is nothing but dxy plane. xy plane. If I have x vector, means for each subparallelogram, if subrectangle maps to subparallelogram, if I keep adding all the parallelogram, it becomes xy plane. xy plane means if I had taken a rectangle here on UV plane, it mapped to some shape on xy plane, that shape it becomes, that shape vector it becomes. So dxy plane becomes A cross B vector. So dxy plane, now it becomes A cross B vector, that is nothing but dx by dui plus dy by duj cross product with dx by dvi plus dy by dvj du dv. Delta u delta v becomes du dv. So dx dy now changed into dx by du into dy by dv minus dx by dv into dy by du and then du dv. So du dv, if you keep apart whatever I am seeing, dx by du, dy by dv minus dx by dv, dy by du, this is called Jacobian. And this is the same thing what we calculated through our way. But our way was not based upon any approximation. Very perfect, very solid, not available in any of the book. This is second way. There is a third way called parametric vector. So parametric vector is similar to the second way. After all, if it is in book, people think in same fashion. So if I have UV plane I have, and then I have XY plane. So in XY plane, it is similar like if I have UV plane and UV plane, AV plane is mapped into a surface which is XY. Now, any point on the surface is x comma y, where x is a function over u comma v, and y is function over u comma v. Similar to if I have xy plane and fxy, z is function over x and y. Now I have uv plane and on top I have a surface, and x and y both, x is also dependent upon u and v, and y is also dependent upon u and v. Consider there is a point P here on this xy surface. This point, the position vector of this point would be P xi plus yj. Can I represent this position vector into parametric vector? Parametric vector in terms of u and v only. Then it will convert into parametric vector as r. That is a sign of parametric vector. R, small r, on top of it, place one arrow mark in braces u comma v. R, on top of place an arrow and then u comma v. This is called parametric vector. Parametric vector equal to xi plus yj. X is now g u comma v I plus h u comma v j. So let leave the right part. Now the p is p. Position vector is now parametric vector, that is r in braces u comma v. So r vector is like a function and parametric function, and parameters are u comma v. Now this is uv plane, this is xy plane, and xy, there is a parametric vector r. Now this parametric vector r will have component along x-axis, and means will have component along x-axis, will have component along y-axis. So component along x-axis is nothing but if it is x comma y, and other portion will be x plus delta x comma y. If it is x comma y, other will be x comma y plus delta y. Okay, if it is parametric, then it will be now in terms of g. So r vector, this point is ru comma v, then it is ru plus delta u comma v. Then this is ru plus v plus delta v, r and bracket u comma v plus delta v. This is ru comma v, x and y. Now this is ru plus delta u comma v. Now if I take this vector a vector and I take b vector, so a vector is nothing but u plus delta u minus v comma v minus ru comma v, and b vector is u plus delta u comma v plus delta v minus u comma v. These two vectors I have to do cross. Okay, so these are kind of two vectors. Now u plus delta u minus u plus delta u comma v minus ru comma v is same as if I divide it by delta u, multiply it by delta u. So it becomes dr by du into delta u I, plus the other vector is dru comma v plus delta v minus ru comma v divided by delta v into delta v, dr by dv. So a cross v, r uth component, partial derivative, r uth component, it is not partial derivative, r uth component and vth component, a vector, b vector. If I do the cross product, then it becomes xy plane. So dxy plane is nothing but dr by du into delta u cross dr by dv into delta v. This will become dr by du cross dr by dv delta u delta v. So dx dy dxy plane would turn up into dr by du into dr by du cross product, vector cross product dr by du dv. So dxy is exactly du dv with extra price, that is Jacobian, that is dr by du cross product dr by dv, where r is parametric vector, position vector in x and y turned up into u and v. So there are three proofs for the Jacobian, and now someone can calculate the volume of the sphere. The volume of the sphere now, square root of a square minus r square Jacobian dr d theta dr, and theta is 0 to 2 pi, r is 0 to a. Now what is Jacobian? So Jacobian is dx by du into dy by dv minus dx by dv into dy by du. So dx and y, x equal to r cos theta, y equal to r sin theta. Dx by d theta is r minus sin theta. Dx by dr is cos theta. Dy by d theta equal to r cos theta. Dy by dr equal to sin theta. If you settle it down, it becomes r square cos square theta plus r square sin square theta square root. Sorry, r cos square theta plus r sin square theta. R is the Jacobian. So r d theta dr is conversion of dx dy. Now square root of a square minus r square r d theta dr. Now r square root of a square minus r square integration is minus square root of a square minus r square. The way I have talked integration, I remember this much. So minus square root of a square minus r square is the integration of r square root of a square minus r square. I believe someone can try. Is it not the case? Okay. A square root of a square minus r square, if I differentiate, then 1 by 2, no, I believe it is not true. So it is minus 1 by 3 square root of a minus 1 by 3 a square minus r square to the power 3 by 2 is the integration. Because 3 by 2, if I differentiate, 3 by 2 would come outside, and then a square minus r square 1 by 2, and then minus 2r. So 2 gone, 3 gone, and minus gone, r square root. So integration of r square root of a square minus r square is minus 1 by 3 square minus 1 by 3, and in braces a square minus r square to the power 3 by 2. Now r is 0 to a. If I place 0, then it becomes a to the power 3 by a to the power 3 by 3. And if I place a 0, sorry, r is 0 to a. If I place a, it is gone. A square minus r square. 0, if I place, then it is a square minus 3. A cube by 3. Minus gone. 0 is lower limit, and it becomes a to the power 3 by 3. D theta is 2 pi. 2 pi a to the power 3 by 3. We talked about the top hemisphere. That is the Cartesian. 4 pi a to the power 3 by 3 is the volume of the sphere. Okay. Now someone can try 3D. So in 3D, in 2D, we have a matrix. If you think about it, there are cross product of two vectors, that is dx by dy, dx by du I plus dy by du j, cross product with another vector, that is dx by dv I plus dy by dv j, or dx by d theta I plus dy by d theta j, cross product with dx by d r I plus dy by dr j. Okay, this results in a matrix where the top row is dx by d theta, dy by d theta, then next row is dx by dr, dy by dr. You can transpose it, only it will matter of negative and positive. But anyway, we take the absolute value, so it doesn't matter. Someone can say dx by d theta, dx by dr in one row, and dy by d theta, dy by dr in a next row. If it is 3D, 3D we are talking Jacobian, then integration over the volume and then dx, dy, dz, dxyz volume, dx, dy, dz. Now this I have to, this full region, volume region, if I take 3D in spherical coordinate system, then theta is 0 to 2 pi. Okay, one plane r is 0 to a and one is phi. Phi is from vertical arc. One is horizontal arc theta, one is vertical arc phi, that is perpendicular to the horizontal arc, and both perpendicular to both is the radius. All three are orthogonal. So phi. So now the kind of x is nothing but a, x is nothing but r, x is nothing but r sine phi cos theta I, spherical code, anyone can see it. Please watch our previous video. Y equal to r sine phi sine theta j, z equal to r cos phi k. Now, for the 3D Cartesian, same matrix you have to use in 3D. dx by dx by, now the plane is r theta r phi plane. So dx by d theta, dx by dr, dx by d phi, first row. Next row is dy by d theta, dy by dr, dy by d phi. Next is dz by d theta, dz by d phi, dz by dr, dz by d phi. Now calculate this matrix and then you get the Jacobian. So dx, dy, dz or dv volume with Cartesian coordinate would result in dxyz by d theta r phi into d theta r phi. D theta r phi is d theta dr d phi. Jacobian someone has to calculate dxyz by d theta rz, theta r phi. So this is nothing but the matrix. Now someone can try. The top row is dx by d theta. So x is r sine phi cos theta. By d theta means minus r sine phi sine theta. Next is dx by dr. So that would become sine phi cos theta. Next is dx by d phi. That would become r my r cos phi cos theta. Similarly, next dy by d theta, dy by d r dy by d phi, dz by d theta, dz by d r, dz by d phi. Now calculate this matrix and it would come as r square. Okay, it would come as r square sine phi. So now the net integration is triple, that is 0 to 2 pi theta, r is 0 to a, and phi is 0 to pi by 2 for the top hemisphere. Phi is 0 to pi by 2, that is top hemisphere. And then it is r square sine phi and then d theta dr d phi. Now r square, if I integrate with dr, it becomes r to the power 3 by 3. 0 to a to the power 3 by 3. Now sine phi d phi. Sine phi is nothing but minus cos phi. Minus cos phi 0 to pi by 2. Pi by 2 is gone. 0 is 1. So net resultant is r to the power 3 by 3, a to the power 3 by 3 only. And theta is 2 pi, 2 pi a to the power 3 by 3. For the top hemisphere, 4 pi a to the power 3 by 3. So this is 3D Jacobian. What about 5D Jacobian? This is what will be required in artificial intelligence. So many features. If that is the case, then prepare the matrix and top row all the features and and derivative differentiated through all the new components. If x, y, z, alpha, beta, gamma, 6 dimension is mapped into u, v, w, and 1, 2, 3, 1, 2, 3. Then you have to prepare matrix like dx by du, dx by dv, dx by dw, dx by d1, dx by d2, dx by d3. Like that, 6 into 6 matrix you have to prepare and then start jumping on it. And that you will calculate the Jacobian. Then dx, dy, dz, d alpha, d beta, d gamma, 6 dimension would become du, dv, dw, d1, d2, d3. So n dimensional you can convert into Jacobian. Priceless work by the people, I believe dual people. Two people, they have worked on this. This is not my fundamental. I had also found this solution when I had, but later I came to know that it is invented by someone else already. That's why I have my own proof. Because through that way, I felt that it is possible to convert one to other. But anyway, it was done, so credit should must go to the people who have already done it. So this is priceless work where one coordinate system can be transformed completely into another coordinate system through Jacobian determinant. So we will do tons of example in kind of Jacobian determinant, and then this is how, because this needs exercise. So that we will proceed upon.